Here we discuss stellar lifetimes, or how long stars live. The lifetime of a star can be thought of as the amount of time that a star spends on the main sequence on the HR diagram. That is to say, the amount of time over which the hydrogen in a star's core is converted to helium. Once the hydrogen has been exhausted, the star moves away from the main sequence. The lifetime of a star depends primarily on the mass of the star. The more massive a star is, the shorter will be its lifetime. Conversely, the less massive a star is, the longer will be its lifetime. When a star is on the main sequence, the star is in hydrostatic equilibrium, meaning that the inward force of gravity due to the weight of the overlying layers is balanced by the outward radiation pressure due to fusion of hydrogen into helium at the core. When the mass of a star is large, the star will need to generate energy at a faster rate to balance the larger force of gravity. This faster rate of energy production results in a higher luminosity and a faster rate of fuel consumption, hence resulting in a shorter lifetime. We can estimate a star's lifetime by taking as a reference the sun's lifetime of approximately 10 billion years. Now, the luminosity of a star is the rate at which energy is radiated out to space at all wavelengths. So luminosity is energy per unit time. The energy production of a star depends on the mass from Einstein's mass energy equation, which says that E equals mc squared. E is energy, m is mass, and c is the speed of light. Now, the luminosity also depends on the mass, but it is raised to the 3.5 power. So luminosity is proportional to the mass raised to the 3.5 power. Since the luminosity is energy over time, we can rewrite this expression to solve for time as energy over luminosity. So time is then proportional to energy, but energy is proportional to mass. So time is proportional to mass divided by the luminosity, but the luminosity is the mass raised to the 3.5 power. So mass over mass raised to the 3.5 power, we write this as the time is then proportional to 1 over the mass raised to the 2.5 power, or more simply that the lifetime is proportional to the mass raised to the negative 2.5 power. We can write the lifetime of a star relative to the lifetime of the sun. We do this by forming a ratio. The lifetime of the star over the lifetime of the sun is equal to the mass to the negative 2.5 power of the star divided by the mass of the sun raised to the negative 2.5 power. If we simplify, we get the ratio of the masses raised to the negative 2.5 power. And if we cross multiply the lifetime of the sun, we get the lifetime of the star is equal to the ratio of the masses of the star and the sun raised to the negative 2.5 power times the lifetime of the sun. So let's work out a couple of examples. We look first at an example where we have a high mass star, a mass of 5 solar masses. So we have then the lifetime of the star is going to be equal to 5 times the mass of the sun divided by the mass of the sun, and the whole thing raised to the negative 2.5 power times the lifetime of the sun. So we have T is equal to 5 times the mass of the sun over the mass of the sun raised to the negative 2.5 power times T sub s. Now we notice that here the mass of the sun cancels because we have mass of the sun in the numerator and in the denominator. And so this becomes then T is equal to 2.5 raised to the minus 2.5 power times T sub s. But remember that the lifetime of the sun is 10 billion years, or 10 times 10 to the 9 years, or we can simplify this as 10 to the 10 years. So we have then that the lifetime of this particular star is 5 raised to the minus 2.5 power times 10 to the 10 years, or T is equal to 1.8 times 10 to the 8 years. We can write this then as the lifetime of a star with that's 5 solar masses is 180 million years. 180 million years. Next, let's look at a low mass star. A star with a mass of 1/2 the mass of the sun. So again, we have T is equal to 0.5 the mass of the sun divided by the mass of the sun raised to the minus 2.5 power times the lifetime of the sun. Once again, the masses cancel, so we get T is equal to 0.5 raised to the minus 2.5 power times T sub s, which is equal to 0.5 times minus 2 raised to the minus 2.5 power times 10 to the 10 years, which is the lifetime of the sun. And so we get, for this particular example, we get 5.7 times 10 to the 10 years, or the lifetime of a star that has half the mass of the sun is 57 billion years. So we see that massive stars have short lives and low mass stars have longer lives.